So, okay. So, we will come a few another example using Norton's theorem. We have to determine that your Rn and In, actually we have discussed earlier this R Norton, actually it is nothing but your R Thevenin, right. So, that we have discussed earlier. So, the way we have obtained Thevenin resistance, same way Norton. So, there is no change there. So, actually we have discussed so many problems, right. So, now your what you call that understanding the things will be easier, and I mean looking at that you can make out. First thing is that when you will when you have a dependent your sources in the network, you just cannot put them up, right. Only independent sources can be put it up. So, if you do so, for example, later solutions are there. For example, suppose if we want that we want to find out on this circuit, if we want to find out that your R Norton, that is R Thevenin, right. So, dependent source is there. So, we can connect a say voltage source, say this is plus minus, right, and you connect a voltage source, say V 0 is equal to 1 volt, right. And in that case what you have to do is you have to sort this, because dependent sources has to be turned off. So, if in the case of voltage source you have to sort it. If you do so, now what will happen? Now, as soon as suppose this current is suppose this current say I 0, this current is I 0, right, coming from this voltage source. Now, as soon as you sort it, so what will happen? The current actually will flow through this circuit, but there will be nothing here, because it is a short circuit path. So, naturally current will not flow through this. That means, your I y will become 0, right. If I y is become 0, then this part it is 2 I y, that is also 0, because I y is equal to 0. So, basically I 0 will be flowing only here. So, that means circuit will be, this current I 0 will be like this, because this is also, then this is also will not be there, and because this path is short, and as this path is short, so current will take this place. So, there will be no current here, I y is equal to 0, because it current generally flows through the short circuit path. So, there will be nothing here. So, this is also not there. So, I y is 0. So, this is 0. Basically circuit remains only this part. If that means your basically 5 I is equal to your V 0, right, 5 I is equal to V 0 is equal to 1, right. That means, your V 0 by I 0 is equal to 5, that is 5 ohm, right, because V 0 your anyway V 0 is equal to 1, but if we do not put 1, this we take only V 0, does not matter, because relationship we are getting V 0 is equal to 5 I 0, that means V 0 by I 0 is equal to 5. Let me clear it. That means, rewriting, although we put your V 0 is equal to 1 volt, does not matter, it is 5 ohm. So, that means, R Norton is same as R Thevenin is equal to your 5 ohm, right. So, this is your what you call to get R Norton. So, this as soon as you sort it, there will be no current through this. If you put a voltage source and independent source, you put it, turn it off, right. So, this is your how we get R Norton, and for getting your I n, that is your Norton current, I n is equal to your I s c. To get this Norton current, we will draw the circuit later. So, in this here we have put V 0 is equal to 1 volt. Actually, here V 0 if you do not put 1 volt does not matter, 1 volt, 2 volt, 3 volt, it does not matter. Basically, you have to obtain V 0 by I 0, and this we told you that how you will get your R n is equal to 5 ohm. And now, when it is sorted, this you have to find out that your what you call that short circuit current. So, in this case your what as it is sorted, suppose for example, current flowing through this, say it is your I, right. Now, as it is shorted, and this 20 volt across this 8 ohm resistance. So, in this case what will happen, then what will be your IY? Your IY is equal to 20 divided by 8, that is equal to your 2.5 ampere, right. So, 2.5 ampere. So, if IY is equal to 2.5 ampere, then this is that dependent current source 2 IY. So, it is 2 IY is equal to 2 into 2.5, that is your 5 ampere, right, that is your 5 ampere. So, now question is that, so here it is your what you call 5 ampere current is entering, right. Now, to get your this I value, right, to get the I value. So, this is 5 ampere, that means your ISC is equal to I naught on. If I write from here, it will be basically I plus 5. So, we have to obtain I. So, to get this, what you do, apply here KVL. So, it is simply 5 I, it is simply 5 I minus 20 is equal to 0. That means your I is equal to 4 ampere. That means ISC is equal to I naught is equal to 4 plus 5, that means 9 ampere, right. So, so things are, I think things are understandable to you. So, if we clear it, that means this one actually your 4 and plus 5. So, that is your I naught, that is 9 ampere, right. So, hope these things are understandable to you. So, that is what has been done here. So, all this write up is here, you can go through of your own, but I have explained everything, right. All this write up is there, you can go through the way I told, same way it is written, right. And so, IY that your Rn is equal to 5 ohm, I told you how to compute. Here I have taken V 0 is equal to 1 volt. No need, actually V 0 by 1 0 directly will get 5 ohm, right. 1 volt, 2 volt, whatever you take, right, it will become 5 ohm. And similarly, this one I told you that through 8 ohm resistance 2.5 ampere, and this one also I told you 4 plus, here much detail in detail, but there KCL we applied and showed you how to get it. So, this is 9 ampere. So, I naught is equal to I short circuit current is equal to 9 ampere. So, everything is understandable to you. Next one is determine the current in 10 ohm resistor of the circuit shown in figure 63 by Norton's theorem. So, you have to find out the current through this your what you call this 10 ohm resistance, right, using Norton theorem. So, first thing is that you have to what you call, you have to first take the 10 ohm out, then you have to go for your what you call that your finding out your Rn and your ISC, IN short circuit current, right. So, so what you can do is that to find out this short circuit current, this is the circuit you have to find out, your short circuit current. So, this ISC is here, right, look how will do it. So, this is short circuit. So, 10 ohm is out now. Now, this is 12 ampere. So, find out the your current through this branch and current to this branch, right. Say for the time being our interest is current through 6 ohm resistance, your this I. So, using current division method, your I will be is equal to this is we want to find out the current through your 6 ohm resistance, that means 3 divided by 3 plus 6 into this 12 ohm 12 ampere that independent current source is there. So, into 12 ampere, right. So, it becomes 4 ampere, that means this I current flowing through this I is 4 ampere, right. Now, this is shorted, this path is shorted, right. That means, this 9 ohm nothing will flow, because this 4 ohm 4 ampere current will take this path, So, there will be no current in 9 ohm resistance. So, current is 0, because this is short circuit, right. That means ISC is equal to IN will be is equal to 4 ampere. So, this is this little bit thing we have to understand, simple thing, but as it is short circuit. So, there will be no current through 9 ohm resistance, all current will go through the short circuit path, that means this 4 ampere current will flow through this short circuit path. So, ISC is equal to IN is equal to 4 ampere. Hope it is understandable to you. Next, that Rn or that R Norton is equal to your R Thevenin, same thing. Next, this current source, it is independent current source, so turned it off, but I mean this will be open circuit, right, and you have to find out Rn in between your 1 and 2. So, this 6 and 3, right. So, if you look into that, this is open. So, 6 and 3 they are in your series. So, 9 and 9 they are in parallel. So, basically your Rn will be is equal to your 9 into 9 by 9 plus 9, that is your, it will become 4.5 ohm, 4.5 ohm, right. So, that is your Rn. So, basically 9 by 2. So, that means Rn we got, so 4.5 ohm. Now, look at the equivalent circuit. Thevenin's theorem, we have seen that V Thevenin and R Thevenin are in series. Here your IN we have got 4 ampere and Rn we have got, and now this 10 ohm is connected across your this R Norton, right. So, in that case you can easily find out that what is your now I10 through current division. It is written I10 ohm, that means current through 10 ohm resistance. So, I10 ohm is equal to, that is your, this is your 4 ampere current, right, this is a current source, this is 4 ampere. So, current division method. So, I10 is equal to your 4.5 divided by your, it is because these are in parallel. So, 4.5 plus 10, right, into this 4 ampere, whatever it comes, that will be your I10. This numerical value is given below, right, that is your current through this 10 ohm resistance. So, let me clear it. So, this is your, it comes actually 1.241 ampere, right. Another one is, next one you take, hope things are understandable too, right. So, obtain the Norton equivalent circuit of the circuit shown in figure your 66, right. We have to find out to determine the current in the 50 ohm resistance, right. So, we have to find out the current through this 50 ohm resistance. So, you have to find out your what you call that your short circuit current, you have to find out Rn and IN. IN is equal to ISC, that short circuit current, right. So, first you have to find out the your Rn and your what you call that your ISC or IN. After that, with that Rn all your ISC, that current source, then Rn and then this 50 ohm, all will be in parallel basically, right. So, let me clear it. So, let us move to this. Now, to get this your short circuit current, this is shorted, right. So, question is that what then how they are, another thing is to get your Rn, these two current source turned off and this is open, right. So, here if you look into that your ISC is your shorted, and at the same time this 2 ampere, just look into this 2 ampere it is upward, right, and this 1 ampere it is also upward. So, their resultant is 1 plus say 2 is equal to 3 ampere, and it is showing the direction is given this way upward, right, and this is shorted, and this 3 ampere is there. That so, basically if you look into this circuit, so basically what will happen as these two things are shorted. So, this 100 ohm and 100 ohm actually they are in parallel, right. So, in that case, that what will be your this thing, whatever what will be your short circuit current, right. So, that is ISC. Now let us go to here, right. So, both 100 ohm resistance are short circuited and ISC is equal to IN 1 plus 2 3 ampere, right, and for as soon as it is open it is in parallel. So, what is happening here that your this one as this path is shorted. So, this 1 ampere current will be flowing like this. So, because it will this current will not flow through this 1 ampere through this 100 ohm resistance, because it is shorted, and similarly this 2 ampere current also will flow through this, because these two are ineffective because it is shorted. That means, my ISC is equal to, your ISC is equal to 1 plus 2, that is 3 ampere. Whatever I was telling, that 2 plus 1, initially 3 both in upward, and finally this 1 ampere current here is flowing and 2 ampere current is flowing here. So, and this is shorted and this is shorted. So, this 1 2 is shorted. So, there will be no current to 100 ohm and no current to this 100 ohm resistance. So, all the current, this 2 ampere take the short circuit path. So, it will be 3 ampere. That means, my ISC is equal to I Norton is equal to your 3 ampere, right. And when it will be in parallel, that when we will try to find out in between 1 and 2 R Norton, because at that time this is open, this is also open, and this is also we have to find out between 1 and 2. So, at that time 100 and 100 ohm are in parallel, right, when it is open. So, 100, so Rn is equal to 50 ohm. So, finally, if you draw this circuit, so In is equal to 3 ampere, Rn is equal to 50 ohm, and this, and we want to find out the current also through that 50 ohm resistance. So, it is 50 and this is 3 ampere. So, basically it is I 50 ohm equal current division, it will be 1.5 ampere, right, 1.5 ampere. So, this is how actually we find out, that means in Norton, that all the things are in parallel, this resistance 50 ohm and this is equivalent Norton, and this is what you call that Norton your current. In the case of Thevenin, V Thevenin, R Thevenin, RL, all are in series. In the case of Norton, IN, RN, and this is basically RL. Say if we say it is RL is equal to 50 ohm, they all are in parallel, and it is 50-50. So, current will be half. So, that means through this 50 ohm resistance it will be 1.5 ampere, right. So, next one is so obtain the Norton equivalent circuit of the circuit shown in figure 69. So, here we have to obtain the Norton equivalent circuit. So, this is your a 30 volt source is there, independent source, 10 ampere your current source is there. So, once you have to find out short circuit current, another is you have to find out the your in 1 and 2 the Norton equivalent circuit, right. So, Norton equivalent resistance. So, in the case of your Rn is equal to R Thevenin. So, in that case, to get this your here you have to find out Rn, right. In that case, this source should be turned off, short circuit, and this current source should be open, it should not be there. So, in that case, what will happen, that means this 1 ohm and 5 ohm, it will be in series, right. So, it will be your 6 ohm and this will be 3 ohm. So, 6 ohm and 3 ohm are in parallel, right. So, let me clear it. So, you will get this what you call, this is short circuit current. For Rn you will get your 2 ohm, Rn will become your first time coming to that Rn is equal to 2 ohm, right, this is Rn. Now, next that because from this equivalent circuit you can easily get it, right, that this is open, this 30 volt source is shorted. So, 1 plus 5 6 and 6 and 3 are parallel. So, 6 into 3 upon 6 plus 3. So, 18 by 9. So, 2 ohm, right. And when it is shorted, we have to find out that your what you call that what is the short circuit current, that we have to find it out. Now, question is that as soon as it is shorted, if you look into the circuit, as this path is shorted, this is shorted, right. So, in that case what will happen, if you will see that 5 ohm and 1 ohm actually are in parallel. If you bring this terminal somewhere here, I mean if you read and bring it here, then because this is all are common. So, you will find 5 ohm and 1 ohm are in your what you call in parallel. That means, what is the current flowing through this 5 ohm resistance, right. So, if suppose this current, suppose if it is I, then this is the 10 ampere current source. I want to divide this current in 1 ohm and 5 ohm, then what is the current to the 5 ohm resistance. So, in that case to the current division, because 5 and 1 are in parallel. So, current division method, your I should be is equal to, this is 1 divided by 5 plus 1, right, into this 10 ampere, right, into 10 ampere. So, basically it will be 10 by 6 ampere, that is 5 by 3 ampere, that is the current flowing through this, right. And another thing is that your we have to find out the short circuit current, because this is the short circuit current is equal to Norton current, right. So, as soon as this is shorted, that as soon as this terminal is shorted, right, then what is this current? Suppose this current is I 0, this current is I 0, right. So, then we have to find out I 0, then ISC will be basically I 0 plus I. So, in this case what will happen, that to get this your I 0 current, then simplest way what you can do is, this is although this is at 0 potential, but for your for easy calculation say we can make a KVL like this. So, in that case it will become 3 I 0 is equal to 30, because if you move like this, it is minus 30 plus 3 I 0 is equal to 0, right. That means my I 0 is equal to say 10 ampere, right. So, I 0 is equal to 10 ampere, and here we got I is equal to 5 by 3 ampere. So, therefore, I Norton, that is equal to ISC, this current is equal to your 10 plus 5 by 3, that is 35 by 3 ampere, right. So, that is my short circuit current or IN. So, let me clear it. So, if it is so, look at this 35 by 3, that is your ampere. So, short circuit current we got 35 by 3 ampere, right, and your RN also Norton we have got 2 ohm. So, that means this is that Norton equivalent circuit, right. So, determine, now this is another example, determine RN of the circuit shown in figure 72 using RN is equal to V open circuit divided by short circuit. So, in this case this is your VOC, this is open, this is VOC, terminal is 1 2. So, that means short circuit current it is 0 here, because it is open. So, no current is flowing through this, and one dependent source is also there, look just before going to that solution. So, this is we have to find out VOC, but as it is open, so this ISC is equal to 0. If ISC is equal to 0, that means this term also 4 into 0 is equal to 0, right. That means this part is all, if it is 0, then your this circuit there is no current 4 into ISC, this current source. So, no current is here also it is going 0 current, because ISC here it is 0, it is dependent source. So, here it is 0. So, then what is happening, this 5 ampere independent current source, this current actually will circulate like this, right. So, this is my your what you call 5 ampere current, this 5 ampere will circulate like this. So, this is actually, if from nodal analysis this is grounded, right, if you so, that means my V1 means with respect to the your reference point. So, this is my reference point. So, my V1 will become 5 into 3, that is your 15 volt, right. So, V1 will be 15 volt, and this is actually common terminal. So, right, if here it is 15, then here also it is 15, right. So, next we will go to that. So, this is first you obtain that V1, right, when it is open circuit. So, if V1 is 15, then that means this voltage actually V1, right, and V1 is equal to 15 volt, right, and this is plus, this is minus. Now, if we want to find out what is VOC, then a arrow means plus, and it is not, no arrow means, if I just keep it as it is minus, and I told you again and again. Now, here you apply your what you call that your KVL. So, ISC is equal to 0. So, it will be 4, it is open circuit, right. So, no need to write 4 into 0, because this is open circuit. So, if we move like this, so it will be minus 12 is coming first, then your minus VOC, here it is, plus your V1 is equal to 0, right, and V1 is equal to 15 volt. That means, if you put V1 is equal to 15 here, so VOC will be 15 minus 12, that is your 3 volt, right. So, it means open circuit VOC voltage we got 3 volt. So, let me clear it. That means, my VOC is equal to 3 volt. So, we have got VOC, we have to obtain now ISC, right. So, in this case, if you got ISC, then we have to go to this circuit. So, VOC we got 3 volt, I explain everything. Now, to get IOC, this is sorted, right. I mean this 1 and 2 is sorted now, because we have to get IOC. So, this is your what you call, it is sorted, and one voltage source is there 12 volt 5 ampere, and as it is sorted, now things have changed. So, this voltage is now say V2, right. Now, question is that this voltage is V2 with respect to the reference, right. So, just hold on, with respect to the reference. Now, question is that your first you have to find out what is ISC, that this is a common terminal, So, this voltage is V2 and this is your minus, right. So, same as before, several times we have done it. So, apply KVL in this mesh. So, you will get 4 into ISC, right, then plus this V2 minus 12 is equal to 0, right. That means, ISC is equal to your 12 minus V2 divided by 4, that is here it is written, right. And another thing is this I is equal to, writing here itself, because voltage here is V2. So, moving downwards, so it is V2 by 3, right. Now, with this you apply your KCL at the, because this is a common node, you apply KCL here. If you apply KCL here, so what will happen, for your understanding, suppose this is this node, right, this current is coming. So, we have taken ISC in this direction. So, current is entering here, this is ISC, 5 ampere is also entering here, this is 5, right, and next 4 ISC leaving this terminal. So, 4 leaving this node 4 ISC, and this I also leaving, I is equal to V3, this is I. That means, ISC plus 5, the incoming current, is equal to your 4 ISC plus this your what you call this I, right. This I means this V2 by 3, right. So, and 4 ISC means expression of ISC you have got it here, you have to substitute. That means, it will be 4 into 12 minus V2 upon 4, effectively it will become 12 minus V2, and this I should be is equal to V2 by 3. So, everything equation you will get in terms of V2, such that you will easily get what is the value of V2, then only you will compute ISC. So, let me clear it. So, hope these things are understandable to you. Now, applying nodal analysis, I told you that it will be now 12 minus V2 plus 5 is equal to V2 by 3, that is your IE, plus 4 into your ISC. So, ISC is equal to 12 minus V2 by 4. So, 12 minus V2 by 4, 4 will be cancelled. You solve for V2, V2 will be 9.6 volt, right. Therefore, your ISC, this expression we have seen 12 minus V2 by 4. So, it is 0.6 ampere, and therefore, Norton resistance Rn is equal to VOC by ISC. VOC we got 3 volt, and this is ISC, and this is your 5 ohm, right. So, we got and this is actually is equal to I Norton, right. ISC is equal to I Norton. So, that is your this thing. So, thank you very much, we will be back again.